In this video, I'm going to show you a very simple introduction to Lewis dot structures of compounds. Before, you have done Lewis structures of just elements, just showing how many valence electrons different elements have. So like this fluorine has 7 valence electrons, one of them is alone. Sodium has 1 valence electron, so it's alone. So because of the quantity of valence electrons, you've learned to call ones that are very close to having 8 electron gainers and ones that are nowhere near having 8 electron losers. So I'm just going to refer to these as gainers and losers. So what happens is gainers gain electrons from a loser, and losers have to give their electrons to a gainer. And when they do that, they can form a compound. So fluorine would like to gain an electron to complete its octet, and sodium would like to lose an electron to reveal the full octet underneath. So what happens is that sodium can orient itself so that the valence electron it had now becomes part of fluorine's octet. So if we sort of think as fluorine as being full, we could draw a circle around it and picture it that yes, it now has a full 8 electrons. And then sodium has none because now that electron it used to have is in that circle. It's now the possession of fluorine. So what we can do is we can draw a Lewis structure of this compound. The way that would look is we would start maybe with the fluorine, and we would say not only did it have 7 valence electrons, it gained 1, and it now has a total of 8. But since it doesn't have the amount it normally had, we would draw it in a bracket, and on the outside of that bracket we would put that ion charge. It's now an ion because it's gained an electron. So it's got a -1 charge. Then we have the sodium. The sodium does not have any electron dots anymore because it transferred it to fluorine. And it doesn't go in brackets because it doesn't have any electrons to sort of corral. I like to think of the brackets as a fence. And since it lost an electron, it's +1. So this would be the Lewis structure of the compound sodium fluoride. Now the chemical formula of the compound would just have the symbols and any subscripts telling you how many atoms of that element were in the compound. So you always start with the least electronegative element, and since sodium is a metal over on the far left-hand side of the periodic table, it's going to have the lowest electronegativity, and then fluorine would come next. And since we only needed one of each, the chemical formula would just be NaF. But it can get a little bit more complicated if we took something like nitrogen that has 5 valence electrons, and if we tried to have it make a compound with sodium. Well, sodium only has 1 valence electron. So if we look at nitrogen, it doesn't have a full octet of 8 yet. So what we would need to do is bring in more sodiums so that we can get those 3 electrons that would be needed to give nitrogen its 8 electrons. And then if we drew the little circle, we could see that the nitrogen now has all 8 valence electrons. So a Lewis structure for this one would be a little more complicated. I still think I'm going to start with the nonmetal, the gainer, and show that it has a total octet now of 8 valence electrons. Got to put it in brackets to show that it has acquired new ones. And because it acquired 1, 2, 3, it's got a -3 charge. And then I have a sodium over here that's +1, and then a sodium down here that's +1, +1. And then a sodium over here that's +1. That would be the Lewis structure of the compound, but the chemical formula would not have as much of that information. We're still going to start with the least electronegative element, which is going to be the metal, sodium. And there were 1, 2, 3 of them, so I'll put a subscript of a 3. And then I'll put nitrogen next, and there was just 1, so it won't get a subscript. So what if there are no losers? What happens is they end up sharing. So in this picture I have fluorine and sulfur, both of which would like to gain electrons. So fluorine would like to fill a circle with 8 electrons, and sulfur would like to fill its octet, fill its circle. So what they could do is they could make those circles overlap, and they could make sure that they have access to 8 electrons in their own little circle. So if we relocate these a little bit, you can see that inside fluorine's circle, there are now 8 valence electrons. But if we look in sulfur's circle, oh, it doesn't have 8 electrons yet. So what we would need to do is bring in another fluorine. This fluorine's going to get its own circle. And that way, if you look in each circle, there are 8 electrons here, 8 electrons here, and 8 electrons here. So when you draw a Lewis structure for a covalent compound, you're going to draw it differently. You couldn't draw brackets around the F and brackets around the S because they overlap like a Venn diagram. So instead what we'll do is we'll draw the F, and we'll draw all these electrons on the outside that weren't being shared. So these two and these two and these two became these. But the shared electrons, because they are shared between these two elements, are just going to become a single line. And that line represents these two electrons, and then I'm going to put the sulfur because it's connecting those two. Now sulfur had a pair of electrons on top, and I'm just going to go ahead and draw it in the same shape that it's in the circles, and it had a pair of electrons here. Those were not in the like Venn diagram area. They only belong to sulfur, so we call those non-bonding pairs. But down here's another bonding pair that connects it to another fluorine, and then this fluorine had 6 electrons that were not bonding. So this would be a Lewis structure for the compound of sulfur and fluorine. Now the chemical formula for this is just going to have the element symbols and subscripts. We're going to start with the least electronegative element, which would be sulfur because it's farthest down and to the left on the periodic table, and then fluorine. There's only one sulfur in this, but there were 2 fluorines, so I'd put a subscript of a 2 on the fluorine.